Okay, the results of the alpha particle scattering experiment led to the development of the nuclear module of the atom. Set the results that suggested that most of the mass of the atom is concentrated in a very small region and most of the atom is empty space. So there are two statements here. The first one is based here. We want to state the result that suggested that most of the mass of the atom is concentrated in a very small region and most of the atom is empty space. So we must give 2 points to which suggested this, 2 results, 2 observations which suggested this. The first suggestion is most of the mass of the atom is concentrated in a very small region. Now, as an example, take for example a football. If I kick a football towards an adult man, 80 kgs, if he is bombarded by this football, this man is probably not going to fall. But if I do the same, I kick the ball high speed at a 2-year-old child who is standing, that child will fall. The difference between the two is mass. They have different mass. So as you can see, it is impossible to, if you have a ball which is moving, this ball finds it easier to push something of less mass forward than to push something of greater mass forward. And you find that when the ball is bombarding the adult man, the ball will bounce backwards because it has targeted or it has collided with someone of a bigger mass. So it will bounce backwards. But when it hits a small boy, 2-year-old, it will not bounce backwards. It will continue forcing the small child going forward, because there is no need for bouncing backwards, considering that the mass of the small child is small. So the same thing applied here. It was observed that the alpha particles, some of them were being deflected by angles, large angles greater than 90 degrees. Now, if an alpha particle is incident to a nucleus and both of them are positively charged, they are repelling each other. So the nucleus is originally stationary. So if the nucleus was light, was not massive, the alpha particle was supposed to, since the alpha particle had already the kinetic energy, it was the one which was moving, the nucleus was supposed to be repelled, and the repulsion should be happening on both of them, but the nucleus was supposed to be more like running away. And the alpha particle was supposed to be more like it is following after the nucleus, because the nucleus will be light. But what was observed was that the alpha particles was deflected back through large angles, suggesting that the nucleus was so heavy such that the alpha particle could not push it forward, which is the same thing as an adult man being bombarded with a football. The football will bounce backwards, suggesting that the adult man has a large mass. So the logic is this statement. So now the next thing is, why do we then say that it is a very small region? Yes, we have understood that most of the mass of the atom is concentrated in a small region, but why small region? It's a small region because only a few alpha particles were ever able to go back through angles greater than 90 degrees. If many alpha particles were going through angles greater than 90 degrees, it would mean that the mass, which this lot of mass, was actually concentrated on a bigger region. But because it is concentrated on a smaller region, only a few alpha particles have the capacity to be incident to this small nucleus. So the same thing with the adult man. If 20 people start kicking the ball at random, majority will miss this man if he is standing, let's say, 20 meters away from us. Maybe one of the persons can hit this man. But if there was a wall which is, let's say, 100 meters wide, and 20 people are kicking the ball, it is likely that the majority of us will hit the wall with the ball. Right? Unless, of course, you are Darwin Nunes in football. Then you would miss this wall, 100-meter wall. Then, so we must understand this thing, that the issue is that this concludes for us that a small proportion of alpha particles are deflected back through small angles. This is what was observed, that a small proportion of alpha particles is deflected through large angles. Number one, the large angles. Number two, a small proportion. This concluded that, okay, if it's a small proportion, number one, then the mass is concentrated on a small region. The fact that they are being deflected back at large angles, it means also that that small region is very massive. That's where all the mass is. So, number one, it's massive and it's small. Because something can be massive and huge and large. So, it's not the same thing that it has to be massive and small. Here, it has to be massive and small because of these 2 points, that a small proportion, number one, that means that the nucleus is small, is deflected back through large angles, then the entire mass of the atom is concentrated in the nucleus. That's the implication there. Then next, a large proportion of alpha particles pass straight through or through small angles. You see, if alpha particles are going to pass straight through without even changing their direction at all, just passing straight through the atoms, it suggests that the atom is made up of large empty space. That's the general conclusion. There is no need for us to over-explain this one. A large proportion of alpha particles pass straight through. This indicates that the nucleus is made of large empty space. State the composition of gamma rays. Gamma rays are electromagnetic radiation. Just like beta particles are fast-moving electrons and alpha particles are helium nucleus. The table 7.1 lists the names of 3 particles and possible classifications for them. Neutrino. Neutrino is a lepton. All neutrinos, there are 6 neutrinos that we know at A level. 6 neutrinos corresponding to 6 leptons. So the neutrinos themselves are also leptons. We must know all the 6 leptons, including the electron, the muon, the pion, and the anti-electron, which is the positron, the anti-muon, the anti-pion, and then the corresponding neutrinos for all of them. So the neutrino is a lepton. Now once it's a lepton, then it cannot be a baryon, because a baryon is a hadron anyway. A baryon is a type of a hadron. What about a positron? A positron, I told you, that is an anti-electron. So a positron is also a lepton. Then we are left with a neutron. A neutron is a baryon. It's a baryon because it is made up of 3 quarks. The up, down, down quark, which we must know. Then it's also a hadron, a neutron, because hadrons are made up of quarks. By being made up of quarks, then it's a hadron. Of course, there are 2 types of hadrons, mesons and baryons. So a neutron is both. Next, the discovery of a particle with an unusual charge was an important step in the development of the theory of quarks. The particle is a hadron with mass 2.19 times 10 to the power of minus 27 kgs and a charge of plus 2e, where e is the elementary charge. Calculate the mass in unified atomic mass unit of the particle. Give your answer to 3 significant figures. Now you must understand that 1 U, the unified atomic mass unit, is actually a unit of mass, is equal to 1.66 times 10 to the power of minus 27 kgs. So if you are given a mass in kgs, like we were here, given a mass in kgs, and you want to convert this mass that is in kgs into unified atomic mass unit, you want to find how many unified atomic mass units are in this. You divided this by 1.66 times 10 to the power minus 27. Because in 1.66 times 10 to the power minus 27, there is 1 unified atomic mass unit. So we divided this by that to find how many unified atomic mass unit. That's what I did here, and we got our answer as 1.32, like that, U. Then finally, determine a possible quark composition of a hadron with a charge of plus 2e. A hadron with a charge of plus 2e has to be made up of 3 quarks, which can be either be up, top, charm, or any one of the combination here. It can be up, top, charm. Any one of the 3 can make, or even up, top, charm, or whatever, up, top, top charm. Any one of those can do. Why? Because all of them, they've got a charge of plus 2 over 3e. So if you add their individual charges, they will give you a total charge of plus 2e, which is needed.